All right, class, in this lesson we're going to take a look at the normal distribution, which is section 14.4. And here is the normal distribution, or you maybe heard of it as a normal curve. This is a histogram showing a normal distribution. Here is the curve that's going through there. Smoothing the histogram out, it gives us what we call the normal distribution. Now, what happens here to have a normal distribution is you have to have the mean be equal to the median and also be equal to the mode. So that is how we get what we call the normal curve. And so the normal distribution within the normal curve is very important to this lesson. U, this weird U symbol, is the mean, the median, and the mode. But here we're concerned about it being the mean usually, because we're dealing with this symbol here. This symbol actually represents standard deviation. And what we're saying is that I've got the mean, and then I'm adding in, sorry, let me go back. I'm adding in a standard deviation here. So this is my standard deviation. This distance here is this symbol here, which is our standard deviation. So let's say our standard deviation was 5, okay? My mean was 10, I don't know. So basically this amount would be 15, and this amount would be 20, this amount would be 25. So it's just saying I've got one standard deviation, another standard deviation, another standard deviation. So I'm just seeing how far my data is away from what actually is the mean. And so over here, if this was 10, then I'd be like, this would be 5, this would be 0. The actual number is 0, and so I'd have a numbers over here, -5. So what this is just getting smaller as we go to the left. Okay, so we're going to talk about area in this lesson under the curve. We're talking about the amount of stuff, the amount of data inside the curve and on these particular questions. Now, the 68, 95, 99.7 rule for a normal distribution is that 68% of your data lies within one standard deviation of the mean, okay? So that's saying the standard amount to deviate from the mean. All of the data lies, well, 68% of the data lies, basically, if, like I said before, if this was 10 and this was 5 up, 5 down, 68% of my data is going to be right in here, okay, in this whole area here, okay? Now the next one says 95% of your data lies then within 2 standard deviations. So this is 2 down, and this is 2 up. So basically, if this was 5 and this was 5, within 2 standard deviations from there and here, so up and down, this will consume 95% of my data from here to here. And last, the 99.7 rule is that 3 standard deviations will give you 99, that's practically all of it, 99.7% of your data is within 3 standard deviations, so 3 up and 3 down, and all this would give me 99.7% of my data. That means there's probably a goofy little outlier over there, or one way down over here. Okay, so that's the normal distribution. Hopefully that gives us a little background information. Properties of it is that it's bell-shaped. Highest point is the mean of the distribution. The mean, median, mode are the same, as I said earlier. The curve is symmetric with respect to its mean. The total area under the curve is 1. Talk about that. It's kind of like the probability. Roughly 68% of data lies within, this is our 68, 95, 99.7 rule. So let's talk about a problem that you're going to see in the lab. It says, assume that a normal distribution of data has a mean of 28. So that means if I had the curve, I know, I'm a great drawer. And right here, this would be 28, okay? And then the standard deviation of 4. And by the way, I would draw it out just like I am right here. So using my rule, if I go up 4 and down 4, that should be 68% of my data. If I go another 4, so from here to here, this should be 95% of my data. Okay, and then lastly, another 4 up and 4 down, this should give me 99.7% of my data. So it says find the percentage of values that lie above 36. Well, where's 36? Well, here's 28. You add 4, Okay, we're at 32 at this marker. You add another 4, right? So we're at 36. Okay, this is the actual number 36. So 36 is 2 standard deviations above my mean. So that means the only thing that's left is 1 standard deviation here, and everything else has been taken away. So what needs to be looked at is that from here to here is 99.7% of the data. Okay, and we're trying to figure out what amount of the data is from here to here. Okay, so what we can do is say that this is from all the way this way to all the way this way would be 100% of my data. If that makes sense. So from all the way left, all the way right, it would be 100% of my data. Okay. So what we're going to do is to figure out what this this leftover part would be right here. Because basically my job is to figure out what is this. We'll call it far right. So we'll just call it R. And then almost right, call it A. I don't know. It doesn't matter. Could call it X. Could call it Y. To figure out what this amount is, what I need to do is take my 100% and subtract the 99.7% that everything else is in here. Okay? If I subtract this amount, I'm going to end up with 0.3. Well, 0.3 is this side and this side together, because the leftover amount includes here and here. So in other words, I need to divide this by 2, okay? And 0.3 divided by 2 should be 0.15. So 0.3 divided by 0.3 divided by 2. Sorry, yeah, 0.3. Okay, so we've got 0.15. So that means this amount right here is 0.15. This is 0.15% of my data. So the only thing I have to do is say, all right, well, it's this amount plus whatever this amount is. So this is my R, far right. And then all I have to do is figure out what's this amount right here. Well, to figure out this amount, what I need to do is say I have, out of the 99.7% of my data, I'm cutting out all of this. Okay? So in other words, I want to take away the 95. So if I take 99.7 and subtract the 95, so 99.7 minus my 95 is going to give me 4.7. So 4.7. Now 4.7 represents the quantity that is on both sides. So the 4.7 represents this amount and this amount together adds up to be 4.7. Well, I want to cut this side off, so I need to divide this by 2 to see how much is actually left over right here. So if I take my 4.7 divided by 2, that's going to give me 2.35. So this is 2.35% of my data. Okay. So hopefully you're seeing how I'm working this out. I'm cutting out the pieces of the bell curve that I don't need. So bottom line, from here to the right, I've got 2.35 between from here to here, and then I've got another 0.15, the rest of that curve. So I want to add my 2.35 plus my 0.15 to get the total answer here above. So if I just add my 0.15, I get 2.5. So the answer is 2.5% of my data is above 36. So it's really a logic exercise of cutting out what we don't need and finding the leftover amount. Okay, so I hope that makes sense. I'm trying to watch it through again if it didn't. Now we're going to talk about z-scores, an area under the normal curve. A z-score represents the amount or the number of standard deviations that a data value is from the mean. Okay, so in other words, back on this number, 36 was 2 standard deviations away from the mean. So 36 has a z-score of 2. So in other words, if you have a z-score of 2, the percent of data above that is always going to be 2.5%. So I have a z-score of 2. It's 2 standard deviations away from the mean. Okay? So you're going to have these wonderful little pop-ups that tell you, based on what you have as a z-score, what is the area, what is the amount, as far as a percentage, under the curve of your data. So it says exactly like this. It says use a pop-up below. Here it is, I already popped it up for you. Find the area under the standard normal curve from 0 to negative 1.68. Well, the thing is that they don't tell you on the table is that well, I told you earlier, is that if I've got my great, wonderful curve, if I go this way, 1.68 standard deviation, so in other words, here's my standard deviation, here's my second one, I need to be at like 1.68, that's right here. So I'm saying, what is the area under the curve here? But we don't ask it here, we're actually asking it over here. The table gives me my answer for right there. Well, if I go this way, negative 1.68, that would give me the same distance. The only difference is my answer on my chart gives me the positive one. Well, this is reflective. It says earlier that the bell curve is symmetric, so whatever my answer here is will be the one that I get over here. So your job is to basically say that, well, if I put negatives on all these, the answers will be the same. So here 1.68 is what I identify as my z-score. This is my answer. It's 0.454. So all I have to do is identify from the table, this is the area under the curve at negative 1.68 z-score. Okay. So here we have two different z-scores, and they're saying, what is the area between the z-scores? So all we have to do is take the larger area and subtract the smaller area every time. So my z-score at 1.4 is over here, and so we get 0.419. My z-score of 0.65 is 0.242. So all I have to do is take your larger and subtract the smaller, 0.242. That's it. That will give you the area between them. So on your chart, you just identify what the areas are, subtract them, and you're going to have your right answer. So here, we're going to get 0.177. Okay. Now what that means is that there's basically 17% of your data, 17.7% of your data between those standard deviations. That's what this area is. The area, when you say area, it's the same thing as a percentage of your data that is at that location. Okay. So formula for converting raw scores into z-scores. Okay, so we're going to be given problems like this. It's going to exactly list your information like that. It says given a mean, a standard deviation, and a raw score, find the corresponding z-score. Okay, so the raw score is in your data set. Like here, the 85. It's just like one of the numbers that's actually in the data set. The mean is the mean that you would have found, and the standard deviation is what you would have found doing the work that we did in the last lesson. So our job to do this is to find the mean, the z-score. So here it is as a formula. Here it is in words. So it's just your z-score. You take the raw score, subtract the mean, and divide it by the standard deviation. It's a very simple formula. So we take our raw score of 85, we subtract our mean, which is 70, and we divide it by our standard deviation, which is 6. You throw it into your calculator, 15 divided by 6, and we get our actual z-score. So that is 15 divided by 6 gives me 2.5. So this is exactly 2.5 standard deviations away from the mean. So this is my z-score. Okay. So and just like what we had earlier, that means that exactly like 36, we know that here we have our 2.5. Sorry, z-score was 2, not 2.5. Oh, never mind. Sorry. So we have 2.5 as our z-score. It's not like 36. It's actually further to the right than 36 was. Okay. Or in a similar type of problem. So here we go. We've got a mean for a data set of 76. The standard deviation is 5. The z-score is 1.6. This one's a little different because it's saying, all right, well, here's your z-score. It's 1.6. What would the raw score be at this? What raw score would I have is if I'm at 1.6? So here we use the same formula. We just have to do a little more work. So I don't know my raw score. I don't know x. But I do know my mean is 76, so I type that in there. And then my standard deviation is 5. So So standard deviation goes here, as I have set up here, and then that's equal to my raw z-score of 1.6. I set it up on the right, it doesn't matter left or right, but your job is to just set it up this way and then solve for x, because its raw score is x minus my mean, just like I have, and then over my standard deviation. So then all I have to do is solve this by multiplying both sides by 5. Okay, and then when I do that, I've got x minus 76 is equal to 1.6 times 5. So I'll throw it all in my calculator at the end. All I have to do then is add 76 to both sides. So if I type this in my calculator, 1.6 times 5, it gives me 8, and then I add 76 to that, and it gives me 84. So x is equal to 84. So 84 is the number that gives me my z-score of 1.6 in this particular problem. All right. So this is just a little bit different than the last problem. It's giving you a different part of the data. So instead of looking for the z-score, we were looking for x in this problem. Okay. Here we go. Then standard normal distribution table. Use it to find the z-score such that 33% of the area under the standard normal curve is below that score. And so what you're going to have to do is think about this problem, because what it's saying is that we've got what is the z-score that 33% of the area is below that score. So what that means is I've got to look at, I've actually got to visualize, and there's no pop-up here to help anything out. It doesn't help us to get our table. We just got to think through, here's my mean. Okay, mean is at 50%, it's at halfway. Okay, so we're saying we're at 33%. Well, to get to 33%, what you need to realize is that 33% is over here. Okay, so I'm trying to figure out what the z-score would be to be right here. What is my z-score for my data? Okay, so we've got 17% of my data left over. Okay, so if I go to my table, I'm looking for what, which I didn't actually copy for us, but when I look at my tables, 1.7 is 0.44. So if I have my area is 0.17, my z-score that corresponds to that is 0.44. So now here, let's talk about what just happened. So 17% of my data is here, 17% of the area. These, again, I talked about earlier, it's like probability is percentage. The 0 doesn't matter, it's like a percent. So 17% of your area is what it's saying is it's the area from the middle to this particular z-score. This particular z-score is 0.44. So the z-score is 0.44. That is 17% away from my middle. Okay, and so what I did to get to 17 again is I took 50, subtracted 33, and then that gives me my 0.44. Okay, so now the z-score again tells me the 17%, and the 17 is what's left over from 50, which gives me 33% of my data below that point. So this is the answer to the question. The curve, the z-score that I'm looking for is 0.44. So if I am 0.44 standard deviations away, the leftover amount would be 33. Now all we have to do to finish that is give it direction. Direction is negative because we're going left of 50, so it's actually negative 0.44 as my final answer. Okay. So if you have any more specific questions, please ask me in the lab through the email my instructor feature. Ask my instructor feature, and I can either write you a video recording or just type one up through email.